11.2D homework. Is the following a quadratic equation? So quadratic equations have to have a second power, have to be a second power equation. So the highest power has to have a 2 exponent. Now, here there's an understood or implied 1 exponent whenever you don't see it. Here's a constant, there's a constant on the other side, so this is not in fact a quadratic equation. Let's move on to the next one. Now, the previous one, they only had one variable with a 1 understood implied 1 exponent. Here we actually do have a second power, but the power of this entire polynomial is equal to the power, the highest, the term with the highest power. So we have kind of a 0 power there, constant. We have a 1 power, which is the second one. We have a second power, and we have a third power. So since the highest power of the entire equation is a 3, the power of this entire polynomial is 3. And since the power of this polynomial is 3, it is not in fact a quadratic. So because we have 3 there, it's not a quadratic. Now, is the following a quadratic equation? So in this case right here, we have a 2 exponent. So far so good. But there's no other powers higher than that. So the actual power of this entire polynomial is a 2. So this one is, in fact, a quadratic. So this one is a yes, and the previous two were no's. Nope, and no. So is the quadratic equation in standard form? Okay, so quadratic equations in standard form look something like this. Ax squared plus bx plus c. Now, I know that's a little confusing, but basically what they're saying is the a's and the b's and the c's are constants, right? So, for instance, a right here might be a 2, b right there might be a 3, I'm just making stuff up, and c might be a 4. In which case, yes, this would be in standard form because we have all of these, the x squared first, the x to the first power, even if you don't see it, is the second one, and we have a constant and it's equal to 0. So this is in fact in standard form. Now, you don't have to have a variable, you don't have to have a 2, right? So for instance, you could just have x squared plus x plus 1, and that would still be considered in standard form. In fact, you could even technically, I think, have x squared plus x equals 0 because the understood or implied constant is a 0 there. So just because you don't see it doesn't mean it's automatically not in standard form. It's an implied or understood 1 coefficient. So let's try this. Now, this is obviously not in standard form because you have your x squared on the right side. You have an x right there in the middle, and you have an equal sign, and you have a constant on the other. So this one's not in standard form for multiple reasons. Now, if it's not in standard form, we want to rearrange it so it is in standard form. So we want to just basically reorder it so all the terms are on one side equal to a 0, and to have it in descending powers. Okay, so we want to get this negative or subtraction of 4x squared, we want to put it on the other side. So we undo the subtraction by adding. Whatever we do to one side, we do to the other. So these cancel out, and that leaves me 4x squared, and this is a positive 14, so we're just going to bring that down, plus 14. And then I'm going to bring down the 7x. Now I don't want the 7x on the right side, I want to put it on the left side. So I'm going to get rid of this positive 7x, understood or implied positive 7, x by subtracting 7x, and whatever you do to one side, you do to the other. Now, you might be tempted to combine the 4x squared and subtract the 7x, but these are not like terms. One of these has a 2 coefficient, the other one has a 1 coefficient, so you have to keep those separate. And then you have a minus 7x, and we add the 14, and 7x minus 7x is not nothing. 7 minus 7 is 0. And now it is in fact in standard form. So let's go over here and do this one. Now, this is not in standard form. You do have x squared and you do have 23x on the left side. They're not in the proper order, and it's not equal to 0. So what you're going to do is, first of all, we're going to set it equal to 0. We need to get rid of this positive 3x on the right. We do that by subtracting 3x, and whatever we do to one side, we do to the other. So those just cancel out, and that leaves me 23x minus 3x is 20x, minus x squared. And that is equal to 0, right? Because 3x minus 3x is 0, because 3 minus 3 is 0. Now, this is still not in standard form because this needs to be in the front. So we're going to have a negative 2x plus 20x equals 0. And now it's in standard form. 11.2D homework, solve the quadratic equation. Now the way we're going to solve this is we are going to use the quadratic formula. But first, before we use the quadratic formula, we're going to put this in standard form, and then we're going to identify something, the a, b's, and c's. Now we already kind of went over the a, b's, and c's whenever we were doing standard form. So for instance, right here we have ax squared plus bx plus c equals 0. So once we get it in standard form, the quadratic in standard form, this is how we identify what our a is, what our b is, and what our c is. So we've already gone over the standard form. So now let's solve for 0. Put it in standard form. Okay, so I don't want this negative x squared on the right. I don't want to be subtracting x squared on the right. So I undo that by adding x squared. And whatever I do to one side, I do to the other. Those cancel out. And that leaves me x squared plus 11x equals 14. Now I also don't want that 14 on the right, so I'm going to subtract 14. And whatever I do to one side, I do to the other. Those cancel out. And that leaves me x squared minus 11x equals, minus 14 equals 0, right? 14 minus 14 is 0. Now, the understood coefficient of your x squared there is a 1, so we know a is equal to 1. The coefficient of the x here is a negative 11, therefore b is equal to negative 11. So I'm getting the coefficients. The coefficients are where I'm getting those numbers from. And then c is the constant at the end, so that means I'm going to end up with a negative 14, which is where I get that. Okay, so we got it. Now, at this point, we're going to plug this into the quadratic formula. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, these are going to give you pretty ugly numbers, unfortunately, but that's okay. We're going to use a calculator to estimate. First, we're just going to plug everything in. We're going to do a little bit of simplification, and then you're going to be using your calculator to find the final answer. Okay, so negative b. So wherever it says a b here, now we're going to plug in the negative 11. So that's negative 11 plus or minus the square root of. We're going to have negative 11 squared. Now, be aware that negative 11 squared is not the same as negative 11 squared, right? So with the parentheses, we're really saying, so with the parentheses, we're saying negative 11 times negative 11, which gives you a positive 121, where in the other case, we're saying negative 11 times 11, which gives me a negative 121, right? And you wouldn't say negative 121 is equal to 121, so that's not true. These are not equivalent to each other. Now, the reason I'm pointing that out is because we want to put the parenthesis here. We want to make sure that we're saying whatever the result of this squaring is, it's got to be positive, right? So a positive times a positive is a positive, and a negative times a negative is a positive. A very common error in this is people make sign errors, so just be careful with your signs. Now we're saying multiplied by a is going to be 1. We're going to multiply by c is equal to negative 14. And we're going to put the entire thing over 2a, which is 1. Okay, so let's simplify a little bit. So you're going to say a negative 11 is a positive 11, plus or minus. We're going to have to simplify what's underneath the radical sign right here. We're going to have to simplify that. So we say negative 11 times negative 11 is 121. We say negative 4 times 1 times negative 14. A negative times a positive times a negative is a positive because we have two negatives that are being multiplied together. 4 times 1 is 4, times 14 is 56. And then we put that over 2 times 1, which is 2. We're almost there. I'm going to bounce around a little bit here, sorry. And that gives me 11 plus or minus 121 plus 56 is 177. And we put that over 2. Okay, so now at this point you're going to plug this into your calculator, and that's going to give you approximations, right? So we would break this apart into the positive 11 plus the square root of 177 over 2, and over here we would have negative 11 plus, I'm sorry, we would have the positive 11 minus the square root of 177 all over 2. And at this point, we're going to have our two distinct answers. We plug this into the calculator and plug this into the calculator. And the approximation on the calculator of the positive one is approximately a 12.15207. And approximately the other one is something like negative 1.152067.